from this.
Sorry, I forgot to turn on the recording. Okay, go ahead.
Yeah, okay, fine. I have to click away this. So yeah. So but now since I think the last 10 years, I'm more into reference, and by reference I basically mean the relationship between us using language to refer to the world as we know it. And here is, of course, a picture of the morning star, which could be the evening star as well. And actually, a morning star can also be a weapon. So we have here a conceptual ambiguity and a referential ambiguity. And
we
that's
don't see it. We still see your head slide. Are you on the first slide already?
Well, on my head slide, you see here a star.
Oh, I see. Okay.
That's the planet Venus,
Yeah.
which is called the morning star and also the evening star. And over here, this is the weapon, which is a morning star as well. Okay, so this is basically the problem I'm looking at, is that language with its words and its symbols and vocabulary has some kind of relations with abstract concepts, but it is very often used to refer to individuals and things in the world. And that is an additional function. That's what I want to talk about. So let's start a little bit with the large language models and their fantastic capacity to connect language to concepts, which I call a generalization. So this is from ChatGPT, actually from yesterday. The only difference in my prompt is the preposition with and for. The patient was treated with, or the patient was treated for, and I got two fantastic lists of results, where with contains all kinds of methods or ways of treating people for diseases that you see at the right side. The left side list is not really perfect because there are some adjectives in there like antiviral and anti-inflammatory, where you would expect also something else there to refer to something that is used for treating people. So as a semanticist and somebody who would build WordNet, and if you would produce a list like this, I would actually criticize you on these two results, like the 12th and the 13th one. But overall, this looks pretty good. And this has been learned from in an unsupervised way from the language that they have collected from the internet. And of course, there is a lot of data on medical data around there. But if you know how the large language models work, and I guess in this series of talks, this has been discussed over and over, so I'm not going to explain this in detail, but you know that this system produces a rank score over the full vocabulary of subtokens that it created by tokenizing the data. So this model could have something like 250,000 subtokens, and every token will get a score on your question. So the first 20 of them, you could say they were all correct. But at some point down the list, there will be words which are not correct, which do not make any sense within this category of words that you find here, which we humans would judge as really wrong. And then there will be good ones again. So somewhere down this rank, the model will produce wrong answers, even though it didn't produce all the answers. So that is what you get because you have a continuous model and there is no discrete boundaries between these categories. Still, the capacity to create these generalizations or concepts or categories is impressive because probably there are not many humans that are capable of producing such a high quality list. Okay, but let's look a little bit further. These models are also pretty good in what I call relative grounding, in the sense that they can connect an expression in the text to another expression in the text and identify them as referring to the same individual. So here is a prompt that I tried out yesterday as well. My daughter gave birth to a daughter. Her name is Nora. What is the name of my granddaughter? So this is a relative expression, the granddaughter of me, which is the daughter of my daughter. And of course, ChatGPT is very good in reasoning over this relationship, figuring out the referential relations, although both of them are she's. The answer is Nora. The name of my daughter, it figures out it cannot resolve from the input that it gave and gives the correct answer, cannot answer that. Now I give it another prompt. My sister gave birth to a daughter. She's also called Nora. I dropped the also. And her name is Mary. I actually misspelled Mary here with 2 R's, but you could also have a Mary with 2 R's. And I asked, what is my sister's name in this case? And then the answer is, if your sister's name is Mary with 1 R, and she's named her daughter Nora, which is totally not relevant, then your sister's name is Mary. Then I ask, who is Nora? Well, Nora is your niece, but there's another Nora in this context, which is the first Nora. So I ask again, what is the name of my granddaughter? That's Nora. And who is Nora? And now it's getting confused. Why? Because it can create this relational identity across expressions, but it didn't produce the mapping from the labels to the actual reference. And should have realized that there is an ambiguity here, that there are 2 individuals related in the text in different ways that have the label Nora. And it doesn't solve this. Another case, if you look at visual data, and this is probably you're familiar with the visual GNOME data set, which is a fantastic data set of images which have been annotated not only with boxes, but also interpretations of the parts of the boxes. So this is the result of the query for a party. It has identity of the different types of things in there with properties such as the colors or made out of plastic or hardwood, but also Q&A data, what are the children eating, pizza, etc. So with this kind of data, models can, of course, relate the visual the generalizations of based on the visual data and connect it not only with vocabulary, language vocabulary, which would label these things, but also relationships among them, being on the plate or having an hair, or activities such as eating. Still, this every representation in a language model, whether this is the representation for the words like chair and bottle, or a representation of the boxes in the images, the transformer representation of these is a generalization over each instance. So that means that it cannot identify this hat as an instance of a hat and then recognize it again. So this example here is illustrating that. If you would give this picture to a model, it would be able to figure out that these are young kittens and also be able to count the different kittens in this image. But it cannot really deal with the information that one of these kittens is actually my kitten called Luna. The others are not identified with these, and given another picture, maybe it can create some kind of similarity comparison between the representation of that, and it can generalize it to being a young kitten, but it cannot identify this kitten as being one specific individual. So symbol image grounding is not the same as reference. So I'm really interested in how are individuals represented in these models. Are they actually represented in these models, which are continuous and not discrete? And what happens with these individuals when you manipulate or operate on these models? So this is another example. So let's start with a famous person like Bach, sitting down behind an organ and playing, and you get this great set of answers with some kind of a comment from ChatGPT that I didn't ask for, but it sounds also like very convincing. that it has all this knowledge and information about Johann Sebastian Bach, which are somehow encoded in this model as data, because this sounds like a good summary. I can do the same for Beethoven. I also get a different list, but yeah, a list that makes sense, like a thunderous toccata, a moving choral, etc. I get a comment that he's actually not a organist, and he's not known for this. So there is a warning over here. So let's go on to somebody else. Let's go to Mick Jagger. Put him in the same context. I get a very different set of results. It all makes sense in connection to Mick Jagger, the singer of the Rolling Stones. I do get a warning that he doesn't play the organ. Actually, I think he plays a mouth organ, but that kind of connection it doesn't make. So there is a warning here that there is something off in the context that I give with respect to this individual. All of that suggests that these people, these individuals, are somehow represented inside the model. So when I question referential grounding, the question is, but aren't they somehow in the model? All right, then we start playing. Let's say we ask it to say something about Ludwig Jagger, and it starts getting confused, of course, and we get a mixture of soulful jazz, but also a classical masterpiece, and other kind of a very creative combinations of concepts. And the combinations and the semantics of these combinations, they all make sense still, but there is, of course, no individual basis for creating this answer anymore. Just for fun, put myself in there playing an organ, and I get really kind of a weird thing. So it does know something about me, computer generated, and a linguistic melody. Great, fantastic. Multilingual composition. Wow, where is it getting that from? So somehow it picks up some kind of individual information properties that it found or associations, and manage to plug it into this context, which is typically not my kind of context, because there is no information about me as a musician or doing anything like that. So what is going on here is what I call a distributional bias, and maybe you should say a distributional referential bias, actually. So all the data has this head and tail distribution, and there are some people who are very famous on which there is a lot of data. And that means that their identity is kind of or the identity of the people represented in the long tail is a weak identity, and gets somehow contaminated by the properties and identities of the famous people. So if you would ask a question like Ludwig Jagger composed what, then the answer you get is what we've seen before, some kind of a mixture of Mick Jagger and Ludwig von Beethoven. So, but in this case, it has more Beethoven flavors than Jagger flavors. Now, if we would take this composition over here, this is the question I do there, and I ask for the answer. I'm not getting Ludwig Jagger, of course, because Ludwig Jagger is not represented, but I get Ludwig von Beethoven. So this is clearly shows that the identity of the head spills over into the tail and identity, as I call that. Now, so I think now we have these fantastic large language models to play with. We should also start looking at part of the data that is not represented and is maybe a little bit more difficult to represent. So I think data by itself is biographical, because we connect data to these individualized people, animals, objects. So my cat Luna, my wife, me as a person, Beethoven, Bach, and all the others in the world. And this information and data changes over time. So there is a history connected to that. So data cannot be detached from this history. It should be interpreted in history as a biography. And this is also true for objects, even though very difficult, and places, maybe a little bit easier. So when we communicate, we as humans among each other, but also when we do this with agents, which is something I'm trying to do more recently, then of course it's not just a matter of encoding the situational context, but we want to also use whatever shared knowledge there is. And the shared knowledge can be the knowledge of the world as it is today, but it should also be the knowledge of the world as it was yesterday. And whatever is shared makes the way you have to look at semantics differently. Because of the principles like Gricean maxims, we don't need to encode everything that is shared anymore because we can already assume that the communication partner encodes this information. So I only need to refer to what was the case yesterday, assuming that you know it, and tell you what changed today. And then you combine that information, that's my assumption, and you get to the interpretation. So this also includes your personal context. So if you have a relationship with an agent, you don't need to introduce yourself over and over and over again. And all the interaction that you have builds up a history or a biography of your relationship. And that will play a role in the way you communicate. So I kind of can make a bold statement that kind of semantics is very often overrated, and we don't pay enough attention to reference because we don't really describe everything all the time, but we do refer all the time. So I want to make a kind of a plea that we need to create not semantic memories as language models, but also episodic memories. And episodic memory means that we need to ground the data to individuals. And I tried to investigate this in two different ways. And the big question is, how do you get this data? And I worked before in projects where we were processing millions of news articles. And we built machinery where we said, okay, take all the news of today. And then if we can process it, we know what happened with respect to yesterday. And I repeat that day over day, and then I can construct kind of a history of what happened in the world according to the news then, of course. Well, in the end, we completely failed doing it because we couldn't figure out from two news articles whether they were actually talking about the same event or incident. So the identity of the events or the identity of the people that they were referring to was not given, and I had to construct it from the data. And that was very difficult. So the way we approach this is we want to collect referentially grounded data to study this and also to build systems and models and connect them to other models like large language models or foundation models. And we have two approaches for this. One is where we look at these events or real-world events. We developed a method that we say, okay, let's start with a kind of a registry of the events that we know that exist, and then find the text instead of first finding text and then reconstruct the event that they talk about. So this is what we call a data-to-text method. And in another line of research, we try to really look at communication within physical spaces and in real time between people and specifically people and robots in this case. So we look at multi-robot interaction. The reason why we do this robot interaction is because I think that connecting language to another modality is now based on data where the language is describing the visual data. And in our communication, we don't describe the physical spaces and the visual data because these modalities are kind of complementary instead of redundant in that sense. So I don't need to explain to you what you see now in the image behind me, like a closet and a painting, or what I'm wearing, because you can see this as well. So I just assume that it's there, and I talk about other things. At some point, the context can become relevant for what I'm saying. Then I will make reference to it. And sometimes the context can become relevant for the interaction. I'm not even referring to it, but it is still being used, and it should be used by you to understand what is going on. Okay, well, let's look a little bit more in detail what we do then, and how we collect this data, and how we try to investigate reference relations in the data. So classically, computational linguists would look at text like these two news texts. They would do some kind of semantic interpretation, parsing, or I ask a language model to do that for me. So I can ask it, okay, mark here the events that happen in the text, like there is a firing event, there's shooting, there's again firing, and somebody and being dismissed. And I could ask the question, how many events are being described here? And which expressions refer to what event? Huh? This is the same as for the things that I did with my Nora granddaughter or with the kittens in the visual data. And I could do the same in another text. So we have here terminated and employment, shooting that didn't happen, and shooting and killing that did happen. And now, of course, the question is, reading this story now generate a picture of the world, a representation, which would be the referential representation of the world. Typically, we do this in what we call an event graph, where we now have, for instance, one unique representation for a event, which was referred to as firing and dismissing, and another event which was referred to as firing, shooting, and killing and using deadly force. So different ways of referring to the exact same instance. Each of them may be framing it slightly different or focusing on different aspects. And there were participants involved, of course. There was a police officer, somebody referred to as he, a white police officer, the officer, that officer, all expressions that make reference to the same participant in a particular role connected to that particular event. So this is the kind of information we would like to generate from the text. But as I said, we failed because it was just too complex to create, and we didn't have enough referentially grounded data to train our models. So what we did now then there thought, well, let's start the other way around. There are people who create databases of events, like this one here, gun violence archive, that has something like unfortunately 44,000 incidents registered with all kinds of properties. Who was involved, where did it happen, when did it happen? So a lot of this structured data can actually be used to create a kind of an abstract representation of what happened in the world, a structured representation. So if we can get this from the data set, the only thing we need to do is get news articles that talk about that particular incident. Then we call these reference text. And then we can find a lot of different news articles of which we know, okay, they can talk about many things, but in the core event that they talk about is grounded to the same incident. So there's the word grounding again. And so of course, I turned this story around for this presentation. But actually, if you start looking for, I also can find Dutch news articles that from this source that actually talk exactly about the same incident and create a cross-lingual data set, which is not a translation from English. And we do this now not through just this gun violence data set, but we do this by using Wikidata as a data source. And Wikidata is created through Wikipedia and other structured data derived from Wikipedia, but now also directly augmented, where people enter structured information about, of course, a lot of other people and places, but also about events. And you will be amazed how much data you can actually retrieve. So we create some kind of a query over the database. For instance, this is a query, I'm not sure you cannot see it, but okay, there is a identifier for it that represents the category of accidents. And if you query it like that, you get a list of instances of the type accident when people manually entered it like that. And then you can enter this, each of them specifically, and you get information about what it is, but also when it happened, where it happened, who was involved. And then you can go to the Wikipedia data in all kinds of languages. And in this case, we look for a Dutch Wikipedia page that is a page describing this disaster in Tenerife. Then I get here a Dutch text that is describing it. And of course, you can see already entities being mentioned here, which have hyperlinks pointing to other ones. And the text itself should actually report on this incident. But then it has links to what we call reference text, which were the primary text on which this was based. So we go back to those news articles and we know they are referentially grounded to the same incident. This is just to show you that we kind of try to formulate this in an explicit symbolic way in a knowledge graph. So this is just, I'm not going to explain all of this, the formal representation where we have a representation for the incident as such. We have the date, we have references to it in different languages that we provide, and other kind of semantic information that we put on top of it. And all of this is automated. So for instance, in this project, we collected various data sets. So here you have different event types that have been queried. So these are the Wikidata identifiers. These are the number of incidents that you just get for free of these types. The secondary reference text are the Wikipedia pages that we find, and we can find them in many different languages that describe exactly that incident. So many where we found all the structured data that we need in order to identify that incident and have some basic semantic representation. In another pilot project, we also looked for the primary reference text. So these would be the references in a Wikipedia page that we then have to collect from the internet. And with this data, we can start investigating a lot of things. So we can, of course, look, this is the one particular instance of an incident. And we can look at all the different ways in which people may reference to that particular incident. And that can be directly by calling, referring to kidnapping as a verb, but it can also refer to the kidnappers. It can refer to it as an attack or as a possibility. Here is another event where you can say that it is here committing a crime. Here it's focusing on the impact of plowing a truck in a crowded mass. Here it is carried out, so that's intentionally an abstract reference. Here's a hijacking, so it's kind of another concept that is evoked. Here's shot, etc., etc. You can see that we use here concepts, representations that we take from FrameNet. This could have been any kind of conceptual representation. It could also have been a representation taken from a large language model. But the most important point is that we get a lot of information and knowledge about the different ways in which people frame or describe or refer to particular incidents. So we get information about the variation, and with that we can train models to get from the text back to the reference relationship. This is just to show you, this is actually the Dutch text that were connected to the same data set that we can get. And you need to be able to understand Dutch to understand this. But we have, for instance, killing over here. And we have a lot of different, not only words or vocabulary, abstract to very specific, to expressions like this one, to chop off somebody's head. To adverbal expressions that imply. So you can see that the way we reconstruct a kind of a mental representation out of the language that we use can be done in very different ways. We can also, all right, oh yeah, skip this one actually, but maybe let's do it like that. So we wanted to now investigate of course, in the text data that a large language model has seen, and also in the text data that you represent to a large language model to interpret, named entities play a certain role, of course. These named entities occur in the text. These are literally the labels that we use to make reference to these entities. We don't know exactly what the referent is. It's not explicitly represented, but we can imagine that a language model will build up a representation connected to a named entity phrase that could correlate to some extent with the identity of that entity. So we are interested in what is the quality of the representation, how close does that approximate the identity of that entity, and what kind of role does it play in understanding a text. And then, of course, we can have a referent, which could be a prime minister, a particular prime minister. But we could also have the concept of being a prime minister. Then there could be a name, like May being the prime minister of the United Kingdom. And there could be uses in text where the model needs to figure out which word or which token, how to represent it, and whether this representation somehow mimics the representation of the name of this person, which is then a person or a prime minister as a concept. Okay. Now, how we investigate this, I have two PhDs that published papers on this. One is Stefan Schouten, and he published this in the Black Box NLP workshop. We use this data to text method to collect a lot of news articles connected to certain topics, like homicides, natural disasters, and you can see here the number of incidents that we have. And if I can move this away, and the number of articles that we found. So these articles, we have 25,000 articles that make reference to 938 homicide incidents that we collect. And we wanted to look at a very basic, simple interpretation task, which is topic classification, and then see to what extent the model would represent an entity in order, and to what extent the representation of that entity plays a critical role for the task. And what would then happen if we would change the entity in a particular way? So the changes that we did in the actual text to do topic classification is entity name substitution. So we could take the name of an entity like Amsterdam and replace it by the masked token. Now the masked token has some kind of a representation, but in a language model, the actual representation here will be probably based on the context. So this original representation is neutral. So by replacing Amsterdam by some kind of a more or less neutral representation, it will try to modify this by using the attention from the context, and in the context it gets some kind of a general entity representation, but probably not the same as Amsterdam itself. Now we can also take a random token from the vocabulary and put that in this position. We can also say now we take a random entity mention. So not just any token, but it should be another entity, named entity label. So we place Amsterdam and Microsoft. But then Amsterdam is a place and Microsoft is a company. So in this case, there could be a shift in type. So we disrupt the representation by taking something that belongs to a different concept. And if we do the same type, but then a different mention, that could replace Amsterdam by another location like Copenhagen. And of course, we can also play with frequency to see what happens if we take a kind of an average frequency entity like Amsterdam and replace it by a super frequent entity, whether this is the same type or a different type, and see how big is the impact of disrupting the representation by introducing that. Now here, this is a few diagrams. The top ones show the accuracy to the left top diagram for topic classification, and then the uncertainty of the model for the same task. And in the bottom one, we actually looked at a masked prediction task, which we could, of course, also easily run with the same model. We either use the language model as is, or we fine-tuned it with some of the data. And you can, of course, see that, okay, fine-tuning improves, but the pattern is more or less the same with respect to using the original entity. We always lose information with substitution, and we lose more. We would expect like random tokens to disrupt more than the mask token, because in the case of a mask token, the context can kind of predict that whatever is there in that mask position should be something like entity type, and that is still performing pretty well. And it's so kind of what we didn't expect is that it would go down also for a random mention, which could be that it is maybe more noise in the random token, but more confusion with respect to the topic for a random mention. And if we keep the type the same, then the performance doesn't really go up or down here. And with frequency, we see the biggest impact. So the replacing it by a very frequent one disrupts the model in making the correct predictions. The uncertainty kind of follows that, and also in the masked language model task kind of follows more or less the same pattern. Now, in another task, we also related to named entities, we use data from this Semifol 2022 challenge, and this is a complex named entity recognition for a lot of different languages. And the complex was interesting for us because we had a little bit wider range of concepts associated with the entities. So manipulating or something with the entities, you would expect more disruption. Complex means there are things like creative writing. We have group over here, we have products, and product names can also be very confusing, of course. And then the languages are listed here. Interesting enough, in this data set, there is the same amount of training data for all languages. And they have all been annotated for named entity expressions. So what we did is we wanted to know what happens if we would replace a token in one language by the token of another language, a random token, when we would train a system. And in this case, that would be a multilingual language model. Specifically, I think it's XLR Roberta that we use here. So we were looking at the Dutch test data. If you would train on the Dutch training data and test it on the Dutch test data, the results are shown here. Now, if you would say in the training data, replace the training data 50% by German data or even Chinese data or random Chinese tokens. Sorry, I shouldn't say the data, but I should say replace the tokens. Then surprisingly enough, we saw that we don't really, I mean, we do get a drop of performance here with respect to Dutch, but Chinese compared to Dutch didn't really drop a lot, and sometimes even improves if it is locations, even though the Chinese character doesn't make any sense within a Dutch context. So this kind of suggested that there is this kind of a robustness in the model that regardless of what kind of tokens that we put in there, it kind of can correct as long as the context, the Dutch context, is clear enough what this should represent. In another research, also on cross-lingual data, but you could also do this in a monolingual way. We wanted to look at a large data set. So this data set has 160 million aligned entity pairs across 120 languages, because we wanted to know, to look for cases where the entity name has a certain ambiguity. And for that, we needed to have a lot of data where we actually know in the training and test data what kind of entity a name is referring to. So here we have, for instance, series, which is in the data 391 times a location, but in almost an equal amount of cases, it's an organization. And there's ambiguity within a language, but also ambiguity across languages. And we looked in this case specific to English, Dutch, and German names. And while we were testing then the named entity recognition, so the capability of the model to determine that a particular token is referring to, for instance, a person or an organization or a location. So we're not talking here yet about identities. So this is actually less than identity. Of course, when we would just train and test on the distributions in a data set, we could see that if we would look at the first layer in the representation and use this to test the model, the performance is a little bit less than if you go to level 3, which would give us more or less the best result. And then higher levels like layer 12, it would go down a little bit again. Now, of course, the initialization of the first layer is based on the lexical representation of the entity name that we have. So if that would be a perfect identity, then you wouldn't expect this to change much if you would go to the other layers. But apparently we get an improvement in layer 3, which means that the context or the attention that you get from the context is adding up to the representation and makes it possible to better decide between these 3 categories. Now, of course, if you take this data set, you have an enormous bias towards some interpretation, both in the training and the test set. So we thought, well, let's look specifically at that bias. And then you can see that actually, to what extent is the identity important? So in the statistics that you see at the right side, again, an initial layer, we looked at the cases where in the training data, this name for the entity is skewed toward a location. And then it already scores immediately 82. But in test cases where it's actually another one, then you can see that the representation of the entity is completely off and needs to be repaired by the context in the other layers. So this indicates the difference between the layer 0 and 3 indicates to what extent the model is able to recover the concept of the entity despite the lexical representation that learned from the training data, which suggests here that it should have been a location, and in this one suggests that it should have been in the training data. It's dominantly a organization, and you can see that here, going from 24 to 85, it kind of recovers from the context, but not as good as it would get there. So this gives you a little bit the idea about how strong the concept is represented in the model, and also how strong the factor is that it can repair this within the context. Okay, now this is what we do with large-scale research on textual data only, and where we try to look at the representation of these entities. And the other line of research, if I still have a little time to talk about that, is investigating how can we actually augment these large language models with what we call an episodic memory. And I'm not sure if you're familiar with that, but a lot of the kind of new developments in relation to applications built around large language models use this concept of a retrieval augmented generative AI, or a RAG, which basically, if you would look at this from a conversational AI point of view, you can use the conversational history or the interaction history that you have to construct the context by encoding the context, as you also would do if you would prompt a generative model. But instead of just giving that encoding to the conversational AI, they first run a query over some kind of external either retrieval index or knowledge graph, retrieve the most relevant information and sources from that external repository, and encode this in combination with the actual conversation in order to generate a response. So this is supposed to prevent hallucination, but also to enable, for instance, storing long-tail data or information in an external repository where the language model itself is a more generic interpretation machinery that can not only reason over the conversation, as I had a conversation about my granddaughter, resolving all the semantic parsing issues, or the shooting in the news articles, but also connected to other information. Now, this kind of a model is, yes.
Can I ask you a question? Because I'm
Yes.
a little lost about what you mean by episodic. Is this all verbal, or is there some other modality involved?
So, I mean, this picture is a kind of abstract picture. A lot of these RAG models are verbal models, so like basically conversational search engines, but it can also be multimodal. But what we do is kind of use this model as well, and this is the next picture, maybe that answers you, is by in a kind of a similar setup where we say, okay, if these foundation models, they can give me an interpretation of a single signal or a sequence of signal in interactions. And these signals can either come directly from for instance, the world through visual or auditory input, or they can come from written or spoken language utterances from participants that kind of make reference either to something connected to what can now be observed or could have been observed in the past. All of that is open. Now, the idea is that if this model is very good in interpreting the signal in this context, then it still needs to be integrated in something that for us represents the explicit referential interpretation of that information. And that is what we try to model as an episodic knowledge graph, that if the interaction proceeds and there are more observations and there is more communication taking place, the result of that accumulates in this graph. And while this graph changes, we have functions that look at the graph properties, and this drives, for instance, the agent itself to also actively ask people for instance, to confirm or to add information or to resolve conflicts. So in this case, this model is grounded in multimodal data. And by the integration, we specifically approach that from a graph theory point of view. So this blue part here represents the graph up to this point. The pink part over here represents the new information that the foundation model would extract from the current signal. That will be integrated into the combination of the two. It will reason over the results of the integration. And on the basis of that, it will formulate things like, okay, this new information results in, for instance, a conflict, or it adds uncertainty, or it represents something I don't know about, or I should know something about. And on the basis of these evaluations that take place, the agent formulates a response. Now, this is a schematic overview of this whole system. I'm going to skip it. It has, of course, some kind of embodiment, but it can also be, that can be a robot, but can also be any kind of collection of cameras, microphones, speakers, and other devices. And we use a so-called event bus where signals are being published in a sequence in time. Processing modules, usually based on large language models, pick up these signals or combinations of signals, produce some kind of interpretation that we store in our episodic knowledge graph, connect it maybe with other external information. We evaluate that, formulate a response, and publish it back into that system. So this video shows how this then works in as an example.
I need to take my pills, but I cannot find them.
They're under the table.
Oh, got it. Thank you.
And this is a very simple referential example to illustrate that we kind of combine different representations, or as we call them, memories, of what took place in this environment, where we use some kind of a temporal container to align these different signals. Signals get processed separately, so we have a sequence of visual signals, audio signals, text interpretations, but we also have this kind of a growth of the knowledge graph during the interaction. And so when we start, Carl is producing some audio, which is then converted into text, but there is also, in the meanwhile, the face of the speaker that was identified and connected to something in the knowledge graph that we identify as the source of the audio, so that we know who I actually refers to in this case. And there is, of course, the information that he cannot find them, and then refers to the pills, where language models resolve these kind of textual representations. We produce some kind of a symbolic representation that we know that Carl is the source of some information that was mentioned about seeing pills, and that he was certain that he didn't agree with being able to see the pills. And then, of course, there is an independent action taking place, because this robot is observing the visual space around it. It will detect something that looks like a pillbox and a table, and a relationship between them. This is something you can do with a large language model. It's connected to the information that was just provided in the knowledge graph, and it will formulate or come to the conclusion that it is necessary to verbalize this information to the participant, and then it creates its own verbal signal, which is then rendered as speech, to claim that the pills were located somewhere and that he's certain about it. And then finally Carl can respond to that, which results in a new state for Carl, that now he does see the pill and knows where the location is. So this illustrates how we go through the different modalities, interpreting these signals in a sequence, but also generating the knowledge as accumulation of this. And this identity plays a very crucial role, and identity is very difficult and to realize. So this is extremely challenging, but it makes the whole modeling immediately very appealing to people and intuitive, which is shown in this video.
Morning. What is your name?
My name is Lenka.
Okay. Is it Lenka then?
Yes, it is.
That makes my day. Let me have a good look at you, so I remember you. Selena, where are you from?
I am from Mexico.
Well, cool. Now I know Florida is from Mexico.
Hello. Hi.
Nice to see you again, Lenka.
Do you know where I'm from?
You are from Serbia. You told me.
And do you know Selene?
Yes, I know her. She is a very good friend of mine.
Do you know where she's from?
Selena is from Mexico.
So the identity plays here different roles, and not only to recognize a person again, but also know who is the source of what information. So we can expect that if we have an agent that communicates with multiple sources, or get them from different people or different devices or from external sources, information accumulates, but it needs to keep track which piece of information came from where, in order to deal with things like conflicts, or to know who would be a good source for new information. And this is for people and their properties, but in the next one we show also that it is important to identify objects and places as a context in which things happen, and that is even more challenging.
Hello. Nice to see you, Linda.
Where are we?
We're in Amstelveen, Holland, Netherlands.
What can you see?
I observed two persons, one book and one potted plant.
We are in Piek's office.
So we're in Piek's office.
Yes.
Amazing.
Bye.
How unfortunate.
Where are you?
We're in Piek's office.
What is missing here?
I'll tell you, Selene. Last time I saw a potted plant, but I do not see it now. And I saw a book, but I do not see it now.
What is new here?
Just words. Selene. Now I see an umbrella that was not there before.
So the important thing is that in order to identify place, in addition to the general information that we have using the IP address that we know that it's somewhere in the Amstelveen, the Netherlands, North Holland, we need to give this place a name, because this is an office and all the offices are very similar. And once this is identified, it is connected to the observations and the context that it makes. So that creates what I call episodic memory of this place in order to identify it, but also to identify the objects within it. So that should be aware of what things disappear, which things appear, and it should be aware what remains the same. And depending on how much remains the same, it can still identify the place. And that is, of course, a very delicate balance, and it's absolutely necessary to be able to construct these memories in addition to the identity of the people. Okay, so this is the kind of illustrates the research that we are carrying out here, and this is my concluding slide. I have not been interrupted by any questions, so I hope they will come now. So my main point is, I think a large language model balances somehow generalization and to some extent specialization in context, but that it's very debatable whether this actually results in what we call this identity. So it doesn't have an extensional model of the world, and it's really difficult to represent discrete identity in a continuous space, because in some way in the context you can modify something in something else. Furthermore, the properties change in time, and the time is now limited to the direct context of an interaction, and there is no permanent memory of all of these contexts and how they are to be integrated. So any man can become a man and or the man in a large language model, but it really never becomes me as a person in what I call an individualized memory. That was it. Thank you for your attention.
Okay, thank you. Thank you very much, Piek. It was very stimulating. There are already questions coming. I'll reserve, if there's some time left over, I'll ask you my questions towards the end, but I'll let the people who have burning questions ask now. Mario.
Yes, thank you, Piek. Very nice presentation, and we learned a lot from you. I want to ask you, please, I noticed the temporal dimension is very important in your model. So for how long this temporal variable can go on? Is it in the range of minutes, days? For how long can it go?
Yes, that is a good question that we still have to figure out. So it is still very complex. There's a lot going on, and a lot of information knowledge that goes in there. What we now typically do is this episodic knowledge graph that we use. We kind of keep it since I think several years. but we don't really interact a lot continuously with this agent. And sometimes we start all over again and we take a new graph and we let it develop again. So I cannot really answer you exactly in how long, but it's very interesting that just as an anecdotal answer is that we forgot a lot about what interactions that we had with the agent. And if we ask it questions, we get all kinds of answers from the past that we don't even remember ourselves anymore. We say, oh yeah, we also told that to the agent. Or yeah, that was somebody else who also worked in our group for a while and has been interacting with the agent. So I don't know anything about the limitations here. I do know that is Selena that you saw in the video is now in Mexico on an internship, and she is trying to train a reinforcement learning module in the agent to make to teach the agent to generate the response that is most effective, because it can choose from hundreds of possible responses to any change, and in that she simulates users. And she had to trim down the whole system because she already in her experiment had she said something a couple of million triples produced, and most of it is just information about interactions themselves, not even about the content. And she stripped off all of that to now 100,000 in her experiment. So there definitely are limits to this approach. Yeah, that needs to be solved.
Very good. Thank you. Thank you so much.
Okay, if you
And
have
good luck.
if you have questions of your own, please raise your hand so that I know you have one and then I can recognize you. In the meanwhile, yeah, there. Okay, Steve, go ahead.
Hi. I don't know if you can hear me. Okay.
Yes.
Good. Okay. Yeah. Interesting talk. I was curious at the demonstration at the end. Now, the little robot guy, you're using GPT-4 with that?
No.
Oh, okay.
No.
Good.
So
What is answering the questions? What's the system you're using?
yeah, so we have several systems in place, alternative approaches for what we call, on the one hand, natural language understanding and natural language generation. So first of all, there is a fine-tuned, I think, what is it? I think a Crossling or a Rosetta model fine-tuned with dialogue act information, so it knows what is a question, what is a statement.
I see.
Like
Okay,
that.
so this is your system, not
Yes.
necessarily based on a GPT
Yeah,
model.
and depending on the kind of question, some questions we just send to Wolfram Alpha to the web. But if we know that this is a question which is where we don't get any answer, generally we turn it into a query to the knowledge graph that we have, the episodic knowledge graph. Then this episodic knowledge graph will come back with all kinds of answers depending on the kind of answer that we get. We then use another model to generate from the graph structure a response to the human user. And as I said, if I make a statement to the robot, there are a lot of changes in the graph. So usually with one statement we get like 100 possible answers that we could generate. And this is the Selena currently investigating, is using reinforcement learning to pick out the right answer so that we can manipulate the user in the right way then to give another input to us. So there are two ways of responses. One is directly answering queries, and the other one is as a result of the changes in the knowledge graph.
So initially though, it looked like you had a multi-layer transformer and you were querying different levels of that transformer for its association with different kinds of lexical knowledge, I think. Was that all? Was that also was your system, or is that somebody else's? Or
I'm not sure exactly which one you're referring to now.
You had level 0, level
Oh,
5,
that one. No,
level
that was
12.
yeah. Oh, those levels. Yeah, that is in an experiment where we used, in that case, it was XLM Robetta that we used, and also multilingual bird, which we fine-tuned on the named entity recognition data, and then we would, in the test case sentence,
see.
we would take the representation from layer 0, 3, 12. We took
Yeah.
all layers actually. Yeah.
Okay, so this is a different difference. Now
Yeah.
this graph modeling you're doing in episodic memory,
Yeah.
are those acyclic graphs in terms of their structure? And are you estimating them somehow from the sequence of actions, or where does that come from?
No, so in the graph model there are several ontologies that are preloaded up front. There is a specific ontology dedicated to representing the communication acts as events.
Oh, so they're templates. They're templates of graph structure.
Yeah, well, they're defined in RDF, so I wouldn't call them templates, but I think probably.
Well, they're not estimated from data.
No, they
Okay.
are based on certain standardized models that
I
people
see.
created to represent certain data information, and in a NoSQL database, you can use RDF to define anything you want in that way, and we use certain things like from schema.org, for instance, to represent very basic things in the world, which you can also find in data. But yeah.
But are you implying that the LLMs do not have this set of capabilities, and therefore you're augmenting your system that might in fact be competitive or somehow integrate with an LLM?
Yeah, no, well, I rather
I'm
see
not
it.
sure what the connection
No,
was.
yeah, and I see, I know what you mean. I mean, we have a lot of discussion about these things in our group as well, and so, but we now currently see this as different layers of information that we have. So the LLM and actually the actual signal itself is a data layer. So when you interact, you produce a whole sequence of signals, videos, audios, text, and stuff like that. And there is a lot of information knowledge in there. The LLM will encode this and encode certain amount of interpretation of every signal. Now we add the other representation, which is a more, I think, an abstraction, a more controlled abstraction of the interpretation, to represent part of this information in a knowledge graph, on which we try to do more explicit reasoning and control the interaction as such, so that we have more control over it. But definitely when we move from the signal to the language model encoding, we lose information. When we go from the language encoding to the symbolic, we lose information again. But on the other hand, we add something that we call more logical driven or more controlled representation. So it is possible, for instance, in this setup, that the model comes to, let's say, a representation about an identity, like it claims to have identified you. Well, basically, it's your picture, which is encoded somehow, which is connected to something which says, okay, this is most similar to this person in my representation. Then in the graph, it will now connect everything to you as an identity. Now, it could be that in the interaction, you say, hey, this is not me, or somebody else says, this is not me, this is somebody else. So it made a mistake.
Right.
So
just to, I'll just finish my question. So your idea here is to sort of integrate the LLM structure, or let's just say phenomena, because I don't actually know what it does. The phenomena with some kind of symbolic structures that will augment it. I mean, the engineering aspects of this are daunting in that you have a 900 billion weight structure of unknown architecture, unknown pretty much anything that you're trying to connect back with small graph structures that I would imagine if it did have a short-term memory, and unfortunately it doesn't, it does not have either episodic memory or long-term memory at this point. Although the speculation is that GPT-5 and OpenAI will have both. I have only seen demos of this, but I haven't seen the whole thing. I just find this very difficult to imagine those connecting together. But I'll
Yeah.
stop there. I'll stop there,
Yeah.
and I'll let Stephen.
Yeah, but you're right. I mean, for me, it's also difficult. This is why I kind of connected to this rack architecture where you basically have a dual system, and there is no natural connection between the two. It's a really engineered connection. And I think we also have an engineered connection. I'm not sure if this is this a correct implementation of a cognitive human model? Probably not, but also maybe it is a way of studying the differences in the relationship. And I just want to put the referential relationship in the equation here to study this. Yeah.
Okay, can you hear me?
Yes.
Maybe you could end your share so that we can see, just do it by direct pinning.
Yeah. Okay.
Okay, so I'll put this on pin view as well. Pin. Well, it doesn't matter about this. Let me use some of the jargon of large language models, and especially ChatGPT, like delve into to motivate what I'm about to say. I'm going to talk about what I think is the deep grounding problem and the deep reference problem. I would like to call what you're doing also to be addressing grounding and reference, but not deep reference. And deep matters a lot because ground means bottom, right? And if you're at some level above the bottom, then you're not really grounding. So let me ask you, just off the top of your head, do you think that a marriage between the best that you can do with large language models, when they squeeze everything they can squeeze out of the textual corpus, spoken, etc., squeezed everything out of there. If you start pinning it with toy image functions or toy sensory functions like what you describe with your little robot, do you think that that's going to answer the questions about the nature of language and meaning and understanding and grounding?
So yeah, I guess that there will be. So I think I'll show that certain identities are kind of in the model. At least it knows how to combine certain knowledge and information to these famous people. So even though there is,
that's already true with the pure verb of word.
Yes, yeah. But okay, but I think I also believe that I can kind of start manipulating these identities in a way and kind of can distort it and maybe even change somebody and somebody else at some point, because it's a continuous space. So it's just a matter of crossing a border, yes or no. And once you cross the border, you're somebody else. And now I think that if we can ground, I'm not sure if that's deep grounding, but if these models can somehow be, let's say we give them the senses and they can actually now connect this to all this perceptual data. I think what is the problem is also that the current architecture kind of forces them to turn any kind of discrete thing into a continuous thing. And so that's always a generalization. So the vector representation of whether this is visual data or verbal data or anything else is going to be generalization. So it doesn't.
I don't understand the relation between generalization. I think I understand generalization, but why do you speak about continuity here? I mean, I know the world is continuous. I know that between norm and a near norma, there's a continuum of appearances. But what do you mean by continuity?
So even though even though the world is a continuity, I think our minds kind of impose discreteness on that continuous world. And sometimes we run into problems because we do that. But I think that is the only way in which we can have a notion of what is permanent in this world. It gives us a possibility to generalize in a different way and also to make exceptions to things. So I think I believe that discreteness is something that we impose on a continuous world somehow, if this is for color terms or other things. So
Not what I'm asking. I completely agree with what you're saying now. So
yeah.
Yes, we name things, and the fact that we name things already imposes is it an X or is it not an X? And
Yeah.
but more than that, we don't just you seem to be focused a little bit more on proper names, but we don't just talk about that. We talk about kinds of things, and the vast majority of nouns, verbs, and adjectives in a dictionary of all those words that ChatGPT and your LLM handle are the names of categories rather than individuals.
Yeah, but this is now coming back to my old hobby before I went more to reference, and that is that these categories and also the vocabularies, they really form a very exotic and almost unstructured jungle. So where I even believe that people may have very different interpretations of these words or labels, and that you cannot really figure out. I cannot look in your head, you can look in my head, we cannot align ourselves directly. And even if our brain machinery would even be 10 times better than this, it will still so coarse-grained that there's no way that we can align our associations from words with our experiences. And we just assume.
You mean one person and another person aligned, or what?
Well, if I'm talking to you and I'm talking about, yeah, just take something, a purple chair in my office, you have no idea. I can see the purple chair, you can't see it. So you're gonna fill in this movie or story now with your version of the purple chair, is it? You might not even call it purple, or you might not even call it a chair, or and then from my experience is that the lexicon is such a rich and complex network of concepts that we still have no idea about. And this is why I move to a reference is who is going to use what word, how to name what thing in what context, and why is this person framing that thing in that way, which there are thousands of alternatives to do here. And we have no idea about that unless we're going to investigate the referential use of these words rather than trying to semantically define what they are. So, and I think if you would give the language model the capability to experience the world now and here and also in time as it is, of course, it will be able to create associations between, let's say, the word cat, and not just the cat pictures that you find on the internet, but it will also be able to ground them to experiences of cat in the context of as far as the senses of this model can do. So, and I think that is the difference between an episodic or biographical organization of the data and something that is taking these pictures of the cats out of the context, out of the real experiences of the world. And it doesn't really matter if I use this cat to associate picture of this cat to associate it with the word, or the picture of another cat, as long as I just feed it with cats and not with dogs in order to create the association. So yeah, so the answer if we would provide LLMs with the capability, you provide them with the capability to ground, in my terminology, ground their language capabilities and also their the multimodal capabilities to experiences of the world. Not sure if I'm answering your question, but
it's a general question, but not a vague question.
yeah.
Your mental model of what it is that reference and grounding are about is very much circulating around some kind of an individual object in a room that two people are talking about, and how do you know which one they mean and whether they mean the same one. But let's start from the real, undeniable, magical strengths of large language models, which is that it's not people in rooms. It's text, generic text, not not text about my room or your room, but generic text. Let's say generic text about Aristotelian philosophy, and they talk coherently. I mean, they write coherently and answer coherently about questions about those texts, and it makes sense to the human being that is using the large language model. But there's an entry there, because I don't think it makes any sense to the large language model. I think the large language model is doing things with words, remarkable things with words, and doing things without grounding, all that stuff. That's the strength. The toy, I'll finish in just a second. The toy robotic examples that you give in your thing are trivial.
Well, in a way, there's absolutely the whole cognitive capability of this agent is less than a child. I mean, okay, a little bit more than a baby of a year, but not much more than that, for sure. And of course, we give it a vocabulary which is way too big for this baby, and stuff like that. But I think that other capability where you can have a discussion with one of these models about Aristotle or any kind of other topic, I really wonder to what extent that model actually understands the philosopher and the claims made. So I think it's really knows how to answer in that way, and it does know how to connect things in that current context in a linguistic manner. It has some kind of a notion of conversationality in what is being expressed. But if I would have a discussion with ChatGPT, and I would be able to convince ChatGPT that it is useless to answer any questions from this point onward, and it would understand me and agree, it wouldn't stop answering questions, is it?
I didn't completely understand the thrust of that. There must have been some intuition.
Well, I mean, if it really would understand our discussion, and we come to the conclusion that it's better that it will never ever answer any question. If it really would understand that, then it would never ever answer a question anymore. I think that will never happen, because it's not doing that. It's not really actually understanding the reasoning and argument we're doing. It just knows how to act reasoning and understanding.
So is your goal in your modeling and in your research to produce a useful gadget that can act like that? Or is it understanding?
Well, my primary goal is to investigate the reference relation more than just only the semantic relations. So that is my main goal, because I think if I can connect identity to reference, I can also investigate perspective. So these three concepts for me are interconnected. So if you only look at the semantics and perspective, we're just missing something out of there. So that is my main goal, and I do this in different ways. But I think that communication and language is actually created and used mainly within a physical space and in connection to kind of a shared world that we have. So I think it also changes a lot if you investigate it in that context. And I mean, the language used in that context is different from the language used in news articles or on the internet or discussing Aristotle, for instance. it's a different type of language. So, and I think that other relationship is more complex.
Well, we've run out of time, so
Yeah.
I just want to point out that my calling in life is to criticize and disagree. It doesn't mean that I can't say with my hand on my heart that it was an extremely interesting talk that you gave, and I learned a lot.
Thank you.
And I thank
Okay.
you for having here.
Absolutely, and very nice approach also, Piek.
Okay, thank you. Okay, great. Well, thanks. I hope to see you guys in another event.
Yes, I'll be sending you and others information about the summer school. I think a lot of it will interest you.
Yeah. Okay, thank you. Okay, bye-bye.
Thank you.
Thank you.